Right. So if you do that, everything's dark.
All set? Or is it too dark?
A bit too dark, yeah.
Too dark?
Have a bit of light, it's fine.
It's really a light.
That's it. A bit more.
Everybody, is that okay?
A bit more.
A little more?
Yeah.
Higher. Okay. Is that okay? Can everybody see the PowerPoint in the back? Yes.
Okay, everybody. Well, welcome to. I actually don't know if this is the 21st or the 22nd. It's definitely 20-something user groups we've had in the last year. Just to give a bit of history and a bit of context, we started in November in the SAS office, and then December was in the SAS office, and possibly January. But I remember it vividly when we had our first user group in a client office, which was that building there. And in that building, I remember saying to the group, we've got this amazing office, if anyone's got a better office than this. And it turns out that Vladimir was in the room. And the following month, we had a meet-up here in the Shard, and that was a legendary moment in Suguki history.
Is it a better office than Olivier's, though? Is it?
I'm not commenting on which is better, but we're
It's
really
got
glad
open
to be.
spaces. I like this open space.
But we're actually, this is not everyone knows this. We're back in the elevator building in a couple of months, so stay with us. Okay, so this is a special event. We've only ever done once a month Thursday night events. A few weeks ago, I was talking on SASL and got into a conversation with Don, talking about hash objects and his book, and he mentioned he was going to be here in the UK. And that's how we ended up organising this event. But before we start, just wanted to hand over to Aftab from Protiviti to say a few words and also a big thanks for hosting this event.
Thank you very much. Hi, good evening, everyone, and thanks very much for joining us. I work for Protiviti. I'm a senior manager within our risk compliance and reg change practice. I also work with our data and analytics team. So, that's across data management, data governance, data analytics, risk analytics, and also, quantitative management. I guess what I wanted to do today was sort of introduce Protiviti and who we are as a global management consulting firm. But before I do, I just wanted to sort of, just throw an open question out there. How many of you in the room have heard of Protiviti or understand what Protiviti does as a consulting firm?
Pronounce it right.
Sorry?
Protiviti.
Protiviti. It's Protiviti. So I guess just as an introduction, so Protiviti is a global management consulting firm. Think of us like like an EY or PwC. We offer deep expertise and deliver across a number of solutions. In the UK, we have 5 solution areas, namely technology consulting, internal audit and financial advisory, risk and compliance, data analytics, and business performance improvement. Now, the types of clients and who we sort of partner.
Oh, it gets worse. And they also wanted to account for date of service for those time periods versus date of billing versus date of payment. So the typical way to solve that problem is you blow out the data and you summarize it again. We started with billions of records. So we said, okay, this is a project for hash tables, and so Paul and I attacked it, solved it. It was a long and painful process. And as a result of that, we learned a lot about the hash object that we decided we wanted to share via this book. A couple of other things, we are giving away 2 signed copies of the book, signed by both me and Paul. My wife in the back is going to hand out cards. All of these cards has a number on the back of it. And then at the end, we're going to run a SAS program, yes, using the hash object, to randomly rank the numbers. So thank you for handing out the card, Celia. And by the way, the reason my wife is here, we're both from the States, but our son, daughter-in-law, and only grandchildren live in the suburbs of London. So that's why we're here, that's why the presentation is this week, because the grandkids are off school this week, and so that's when we come here. So, hash tables. We think they're powerful and flexible data structure. But too many people, when they think of hash tables, think of just table lookup. They are a great table lookup tool, and neither Paul or I, ever want to diminish their use for that purpose. However, they can really be used for a whole lot more than just that. So here's a short list. They include many of the database functions that you would see in a database. Insert, add, delete, etc. They can be used for data aggregation. We're going to see some examples of that in this book at multiple levels. Non-hierarchical aggregation, like I mentioned in the introduction. Hierarchical aggregation, just like, for example, what proc summary can do for you. They can be easily parameterized. And the big complaint about, or the big concern about hash tables is memory constraints. That's not a deal breaker. There are lots of things you can do. I don't get a card, I don't need one. There's lots of things you can do to deal with the memory. We've got an entire chapter in the book on options for optimizing memory management. And quite often, using a hash table can be orders of magnitude faster than traditional SAS approaches. The sample data for this book is for a fictitious game that we're going to call Bizarro Ball. And Phil Holland has asked me to tell the story about how Bizarro Ball came to be. Alan Bowe, the conversation that he and I and Paul had was about the fact that he liked the Bizarro Ball because it was a rich data source, even though it was about a game he didn't really know. And so Alan Bowe has done some things on it, packaged it out on GitHub. I'm a baseball geek. I love baseball. My wife and I go to about 30 baseball games a year. And I was writing for a blog, and baseball has gotten very much into analytics. Well, guess what? SAS does analytics. So people would ask questions, well, what does the data say? So I would go grab the data and say, this is what the data says. And that got me interested in baseball data. At roughly the same time Paul and I were talking about the book. And I said, that would be really good to use baseball data. I know a lot of folks overseas don't see it, but it's a really rich data source in terms of the number of different tables, the requirement to do aggregates and joins. So we talked to SAS, we talked to Major League Baseball. The first year and 9 months of the 3-year effort to write the book was getting permission to use their data, which we never got. I'll shortcut the rest of the painful story about that. So I basically said, okay, I'm just going to make up the data. I'm going to write hash table programs with Paul's help to generate the data. And so that's what we did. But before I did that, I wrote to a few of my friends from my baseball blog and said, if you could change the rules in baseball, what would you change? Because I'm writing this book, I want to use different rules, etc. I'm going to be generating the data, so I'm not going to adopt every single one of your rules. And one of my friends wrote back and said, I'd be glad to make some suggestions for this thing, I guess you could call it Bizarro Ball. So that's the source of the name. So as I said, it's conceptually similar to baseball. We'll talk a little bit about that in just a bit. A variety of data sources, player candidates. So you're going to have a player ID, a surrogate key for what team they play on, what their name is, all sorts of demographic information, what position they play, whether they're left-handed or right-handed. So lots of different variables that could be used as class variables for data aggregation. There's another data set called at-bats. In a baseball game, is 9 innings long. You play until each team plays 9 innings. Sometimes it's 8.5, sometimes it's extra innings. Our data, I don't worry about any of that, but every game has roughly 45 at-bats for every team. So once again, if you blow that out by the number of games there are, that's potentially a lot of data. Then there's also data, and this mimics what the real baseball data looks like. A record for every pitch in every game. Every game, and once again there's thousands of them, can have upwards of 300 or 400 pitches. And then we made 32 teams. So that's our data. So let's talk a little bit about the things you can do with a hash table. We talked about it as having many of the functions of a database management system. And so the 4 core capabilities identified of a database management system is create, read, update, and delete. And I'll let you decide or read for yourself what the acronym CRUD stands for. It stands for CRUD. So, and if you look up CRUD in Wikipedia, there's actually an entry for it as create, read, update, and delete. So, hash tables as an in-memory database. We want to get a list of those players, including their name and other demographic data. And by the way, this is going to be a code-intensive talk. The PowerPoint, we'll figure out a way to make this available for everybody to download, right? So you don't have to worry about taking pictures or whatever. So we're going to declare a hash table called triple. We're going to load it from our at-bats data and load all the data where a player hit a triple. We're then going to read the Bizarro player candidates data set with a where clause for the given team. So what this program is going to do is tell us every player who hit a triple. If you listen to a baseball game in the States or you watch it on TV, it's amazing how much they go into detail on things like that. The announcers will say, well, this is the first time in Major League history that a player has done X based on the current scenario. So, a lot of these are things that people actually care about. So, we're going to create the hash table of every player who's hit a triple. We're going to read the player data, and we're only going to keep the data who've hit the triple.check. It's object-oriented syntax. It's saying, is the data that I just read into the PDV, is that record based on the key value, which is the player ID, is that player found in my hash table? So here's a case of a table lookup and subsetting, a database management function. Joining 2 tables. In point and fact, table lookup is a join operation. You're looking up the value into another table based on a key. Lots of folks use proc format to do that, and that's a great tool to do it, but proc format allows you to look up one value. A hash table allows you to look up lots of values. So we're going to create a hash table, once again, of everybody who's hit a triple. We're going to include the data fields to be joined or looked up, in this case, distance and direction. Those are 2 of the data fields. We're then going to use what we call the unconditionally executed. I used to call this a conditionally executed set statement, but Paul corrected me. He says, well, you're never really executing it. If 0, then set. If 0 is never true, what that set statement does is define all the variables to the program data vector. And hash tables need to have all of their variables defined. So we're defining the variables to the program data vector. When we do a lookup with a hash function, if the record isn't found, the PDV is left unchanged. So it could have the values from the previous execution. So you're going to want to use a call missing before you use the find function. So we're going to do a call missing, and then we're going to do a do while, triple.doOver basically says loop through all of the rows in data set triple and give me a count by using a sum function and then output. So this is going to give me a join and a data aggregation operation. So for each player who's hit a triple, get the distance and the direction and output the row. Since we're doing a left join, we want to only output those cases where they were in the triples, where they were in the input data set. We wanted to do a full join, we could output everybody. We could also split a data set based on the value of a variable using a hash table. So this is program 611 in chapter 6. Didn't mention it before, but all of these slides reference which program in the book references those. So once again, we're going to create a hash table. It's going to contain the data for each distinct value. All the rows, that's what the multi-data argument does for us. We need a key in our hash table. Doesn't matter what it is, so we're just going to use underscore and underscore 1. This data step is only going to execute one time for each by group. We're assuming the data is sorted, so what we're going to do is we're going to define a hash table to contain all of our data. As we read in the data for a given team, we're going to add it to our hash table. Once we've read the data for an entire league, we're going to output it to a data set. And the other thing about the SAS documentation for the hash object is it really doesn't tell you the power of everything it can do. In the documentation, every method call has a character constant as its argument. Well, the arguments can be character expressions. So we can say create an output data set by concatenating work.league with an underscore as a separator and league. So we can create a data set called league underscore 1, league underscore 2, etc. That was the other reason we wanted to write the book, was to expose that. So it says we're going to use a DAO loop to read all the data for a given by group. We're going to add it to the hash table, and we're going to output the data set. And then we're going to clear it so that when the data step executes a second time for the second by group, we're starting with an empty hash table.
So Don, just a question on the previous one. You said you make the assumption that the data set's sorted. If it's ready to memory, it still needs to be sorted before you can use that?
If what?
So can you use that data without it being sorted? You made a comment in that you're making an assumption that it's sorted, but if you're reading it to memory.
The next to the last slide of the presentation is a list of articles that Paul and I have written on communities.sas.com, and one of them is how to split a SAS data set without assuming it's sorted. So
even
this
though you're reading it
particular
to memory, you
program,
still need it to be sorted.
it needs to be sorted because of the way we're writing the down loop. But you can do it without the data being sorted.
I see. Cool.
And as I said, we do have an article on communities.sas.com about that, and I think it has 3 different approaches, techniques to do that. So, the last point about an in-memory database, Chapter 7 talks about, uses our data to create a star schema dimensional structure. For those of you who don't know, a star schema is basically, we've got a fact table in the middle, and then surrounding it, we've got what we call dimension tables, which contain information about the various attributes. You know, details about each game, details about each team, details about each player. We don't want to carry that in our fact table, because that would make it very wide in addition to very long. Plus, that data could change over time. So, let's move on to the next example, hash tables for simple data aggregation. Program 8.1. In baseball, there's this concept called a slash line. The program on the cover of the book calculates a baseball player's slash line. And what the slash line is what percent of the time do they get a hit? It's the batting average. So let's go ahead and look at those metrics. What percent of the time do they get a hit, batting average? What percent of the time do they get on base, OBP, on base percentage? How many people have heard of the book Moneyball? Okay? The concept of OBP, on base percentage, being more important than batting average was the key concept that Billy Beane, the general manager of the Oakland Athletics, came up with. He said, you know, if you get on base a lot, so that you're on base more often than somebody who gets more hits, you're still just as valuable. The next one is the slugging percentage. The slugging percentage is basically a batting average weighted based on how many bases you got. So if you hit a home run every time you go up to the plate, your slugging average is 1,000. If you hit a home run half the time you go up to the plate, your average is still 1,000. So we're going to build our table called slash line. We're going to define the format for our variables. So we're creating our hash table. We're specifying we want it ordered. We don't really need it ordered yet, but by doing that, we're basically saying when we create an output data set, it's going to be ordered by the batter ID. We're going to enhance that a bit later. We're going to define the class or the grouping variables as a key, which is the batter ID. Define our metrics. We adopted the convention, this is just a convention, we said if there are variables we need to keep in the hash table that we don't want in our output data set, we're just going to prefix their name with an underscore. That's a convention that you'll see us using in a bit. So we now go through a DAO loop and we do all the calculations. And when we output the data set, we can use a drop equal option to say drop equal underscore colon. That says drop all the variables that begin with an underscore. Once again, the argument to the output function, the value of the quote data set argument tag need not be a character constant. It can be any character expression. So we're reading all the data in a DAO loop. We're initializing all of our variables to missing. We're doing a lookup, doing all the calculations, and then we use the replace function. The difference between the replace function and the add function, the replace function says if the row already exists, just replace it. If it doesn't exist, add it. So the replace function makes it possible for us to not have to worry about if the row already exists in our data set. And then when we're done, we output the results. So there's our sample of data, our batter ID. Notice the formats and labels, etc., were all inherited from the attributes in the data step, even though we didn't use an output statement. We used an output function of the hash method.
Sorry, Don. What's the key used to either replace that line or is it the whole thing?
Excuse me?
I didn't see where the key was defined for what that record, or for what represents the record.
Okay, back up. I overwrote it in the previous one. Oh, wrong way.
It wasn't on my slide. It wasn't a complete data set.
It was 2 programs on 2 slides.
Oh, there's just a dual. Okay, cool.
We're just loading, bro.
Yeah.
Define.
Okay, cool.
Okay.
Sorry, I didn't.
Yeah, sorry. I should have mentioned that. As I said, this is a code-intensive slide. How many of you have had to create unique counts? Distinct counts? That's a real pain, isn't it? Proc means doesn't do it. Proc summary doesn't do it. You can do it in SQL, or you could do it in a data step. Well, it turns out that calculating distinct counts is reasonably straightforward using a hash object. That was the other challenge of the project that I mentioned at the beginning that Paul and I first worked on, is every report had to have a count of distinct patients.
So why not just use ProCSCO?
Because it's not nearly as efficient. And in that particular case, just doing one of the 14,000 different aggregations that would have been required would have taken an overnight run because of the volume of the data.
And what did it take instead?
For that particular project, they were able to do it with some partitioning, all 14,000 or however many there were different levels of aggregation on an overnight basis.
But didn't you say that was what you could have done with ProCSCO anyway?
So 1 out of 14.
One out of 14,000
I see.
was longer than overnight.
Okay.
To just do a fraction of what they wanted to do to process it, it was monthly data. We did the estimates and it would take 7.5 months of processing time to process their monthly data using a proxy-equal approach. So that wasn't an option. So we're going to define our table slightly differently, because one of the things you also want to do in baseball data is you want to know, okay, a player gets 500 at-bats in a year, but how many games did he play in? We need to know from our at-bats data, how many distinct games did a player play in? So we're going to add some additional key fields here, okay? So we're both doing enhance the aggregation to get unique counts and multiple levels of aggregation. So we're going to want aggregation at the league level, the team level, and the batter level. And we're also going to want to get distinct games at each of those levels. So we're adding additional key fields. So key and data fields. So the team name is now a key field. The league, they're also included in the data. And we're adding another aggregate field called games. We then define a lookup table for our players. Once again, multiple slides for this program. We're doing a rename. We're going to allow for duplicates. Players do change their names throughout the year. There was a big joke a couple of weeks ago about Zach Britton spelled his first name Z-A-C-H, and he had to get permission from MLB to change it to Z-A-C-K. Why? Who knows? But he did that. But players do sometimes change their name. So we're going to build a hash table so we can do a lookup for the player name, because the output data set before had a player ID number. There are hundreds of players. You don't remember them by their number, you remember them by their name. So we're going to define a lookup table for the team and the name. So we're doing lots of lookups here at lots of different levels, which require lots of different sorts and merges. We then define another lookup table for the league name. So from our input data, we need to look up the player detail, which then tells us what team they're in. We then need to look up in the team table to get the league information, and then we need to look up into the league table to get the name of the league. And now what we do is we create another hash table called U, which has the same keys, except we also added game SK. And we'll see how we use that in a minute. So the U hash table is going to be used for nothing more than to identify, have we seen this league, team, batter, and game before? Because if the row that we're going to be reading in later isn't in that table, we need to add one to the number of unique games. If they are in the table, we don't add one.
No, I'm sorry, I've got one other question. So, I mean, okay, given this was maybe 9, 10 years ago, right? But is there a kind of point at which volume becomes material? Because, and even if it's kind of moderate volume, data volumes, as in, you know, n x number of millions, I use hash tables quite kind of a lot. But when doing those performance tests and
Paul and I have never encountered a project where memory constraints were not reasonably solvable with a variety of partitioning schemes, which is an 80-page chapter in the book of all the alternative techniques, roughly 80 pages.
So the question is simpler than that. It's, if you have a table with 10 million rows and you want to do this lookups. Now given, as I said, I put my hand up at the start, I mostly used it for lookups, but from a performance perspective, you know, there were cases where the difference between the two, in fact, in some cases, albeit by minuscule margins, ProcSQL was faster. So my question really is, are there any considerations around data volumes and when hash tables do really start to come into its own, as opposed to just
No.
using ProcSQL?
You know, anything that's got a reasonable, you know, if you're processing 17 records, it doesn't matter. But any,
Yeah, but that's not the question.
any reasonable data volume, hash tables will compete, if not greatly outperform traditional SAS techniques. Paul created code, this was 15 years ago, when he had to write his own hash functions, hash tables, hash objects before SAS had them, and he took a project for, once again, an insurance company for a southern state, and he created their star schema on an overnight basis where before it took weeks. And he replaced traditional SAS code with the hash object.
What was the source of the data on this project?
What?
What was the source of the data on this project? Was it SAS tables or was it Oracle data?
It was probably external files, but just creating the part of, once it was in SAS, that's where the hash tables contributed. So, what we're just going to do now is chapter 8 /line with unique counts. What we're going to do is we just move the code that does the search and calculations to a link return block because we want to be able to execute the code from multiple places in our program. How many folks know about the link function? Just a very few. I encourage you to look it up. The link function allows you to say link to /line, run this code, and when you issue the return in that data step, it goes to the line after the link. We'll see an example of that in just a bit. So what this does, if the add method returns a 0, that means the add was successful and added a row. That means it's a new game for this set of keys. So we're counting unique gains by doing that. So that's how we added unique gains. So we're setting all the fields to missing. So let's go to our DAO loop again. Setting everything to missing. We're doing a lookup for players. Once we've looked up the players' information, we can do a lookup for teams. Once we've done the teams lookup, we can do a lookup for leagues. So we do our 3 lookups, each which have separate sets of keys. We link to /line to do our calculation. We set these fields to missing, including, notice, the player information. So we link to /line again. That gives us the team level aggregation. We now set the team field to missing along with the other things, link to /line. So we've done 3 levels of aggregation. And the book has other examples of doing this that don't require repeated code. Question, Peter?
It was just stunning. There's so much hidden behind players.find.
Yeah.
The syntax you're showing there is so brief. We're providing, behind the scenes, all the parameters that you would like to find the right player, statement lead, from that set statement where the column names are coming in.
Right.
And it's just, so it hides the complexity that's going on because you can just say find open bracket, close bracket.
Right. Exactly. It is an in-memory database. So once again, we look up the player name and team. Once we've got the team name, we can look up the team name and league, because the players.find data had this player plays for team 17. But who is team 17? I'm a baseball fan. If somebody were to tell me the team IDs for the baseball teams, I would have no clue which team that is. Notice that we don't need to do sorts and merges in between each of these, so we don't have to sort and merge by player ID to get the player information, then sort and merge or SQL by team ID to get the team name, and then by league ID to get the league name. It's all handled in memory. We do our team level calculations, and as I said, we do our league level calculations. And there's our output. For the Eastern League, the team Bears, and for Terry Allen, who plays for the Eastern Bears. And notice our output data set, because we use the ordered option, is in sorted order. And we're taking advantage of blanks sorting before values, so we get the aggregate at the league level, and then at the team level before at the player level.
You could always use an underscore type.
Yes. And we've got, once again, one of the challenges we had in the book was one of the best and worst things about SAS is there are countably infinite different ways to solve any given problem. And so lots of the problems that we had in the book, and we've said a lot in the book, and we will revisit this example in chapter X. This example is revisited in chapter 9. You can also parameterize hash tables using the macro facility, using parameter fields, and using what we're going to call an array of hash objects. But you can't use SAS array. If you try to create a hash object and make it an element in an array, you get a message that it's not a scalar field. It turns out that there are actually 3 different data types in SAS. Everybody thinks about character and numeric. Those are referred to as scalar fields. Well, there are non-scalar fields, which are hash objects, and hash iterator objects, which are sort of casually referred to as non-scalar fields. So the hash object is not compatible with arrays. But we can create a hash object whose entries are other hash objects, sometimes called an associative array. And when SAS first came out with the hash object, they talked about calling it the hash object an associative array. I wish they would have. So we're going to talk about a couple of these.
It's you that stopped them.
What?
It's you and Paul that stopped them calling it. Made them.
It would. Paul knows a lot more about this, but if you ever, how many people here either know or know of Paul Dorfman? Okay? To call him brilliant would be an understatement. One of my biggest challenges in writing this book with Paul was he would write something and I would say, Paul, our readers aren't going to understand it. He says, oh no, it's simple, it's obvious, I know this, everybody should know this. I said, Paul, do you think I know a lot about this? Well, of course you do. He said, I didn't understand what you wrote. At one point, we actually had to have a couple of the reviewers come back and say, I don't understand what you're talking about, Paul. And luckily, those were people who Paul knew. So he says, oh, maybe you're right. So if you ever want to get Paul off on a tangent, ask him all of his frustrations about why they didn't listen to him on his suggestions early on. So, we're going to talk about, we call this a simple HOH, hash of hash. So we're going to define a hash object, and we're going to say that the key is the name of the table, and the data is going to be H and the table name. So we're defining the hash object that contains other hash objects. The key has to be a scalar field. We're going to define a data step variable. Notice we didn't tell it what table to load. We haven't done anything with it. All that does is it defines a data step variable of type hash which is also referred to as non-scalar. So that's the value that we're going to use there. So the comments are a bit out of order. So we're now going to assign the value of table to be our at-bats data. And now, instead of using a declare statement to define the hash object and assign the value, we're using the new operator. H is a new hash, load the table, load the data set, DW at-bats, define the keys, define the data, define done, add this to our hash of hash tables. Define a table, create another hash object, add it to our hash of hash object. So we now have a hash table that has two hash objects, each of which we want to process. So we can now iterate through that hash of hash table. So it says we're going to define the data, add it to the table, define a data set, define it to the table, and we can now iterate through, and this is just a very simple demonstration program. We're using a hash iterator, which allows us to loop. That was the other thing. Paul insisted we couldn't say loop, we had to say enumerate. I know, Peter, you're laughing because you know Paul. Okay, so we have to enumerate through all of the hash object data rows using a do while with the next operator. You get the attribute, how many rows does it have? The whole point of this example was to demonstrate that we've got two hash objects. And if we look at the notes, I'm pretty sure the notes are down here. Notice it says that we read 287,304 from DW at bats and 875,764 objects from the pitches data set. And notice the listing as we loop through our hash object to say how big each one was. This program does nothing useful other than introducing the concept of a hash of hash table.
I mean, the way you build the hash of hash is, it would be easier to do just a list, because there's only two objects in there.
Right.
But when you get to 14,000, I can see
When you get to
more
14,
problem. But still, you're using plain syntax to build
Right.
14,000.
Right, but we're going to use hash of hash in a bit.
Okay.
So we want to calculate aggregate metrics at 5 different levels. Remember where we said we'll just blank out the player data, player field to get team level aggregates. We'll then blank out the team to get the league level attributes. Well, that only works if you're in a hierarchy, and that's only reasonable in this case because you had 2 or 3. Well, in this case, and this in baseball is something called splits. That's why we refer to it as splits in the program. There are splits for everything in baseball. As I said before, you will see announcers say, on Tuesdays after a day off, when this batter is facing a left-handed pitcher, this is his batting average. I kid you, Celia, is that right?
Yeah.
She's a baseball fan too. I converted her.
Very nice.
So we want to do it by player, by team, by day of the week. I said they cared about day of the week. By month, and by player and by month. So yes, we could do a player, team, day of week, month, and then navigate through the type values to figure it out. But oh yeah, we can't use proc summary because we want unique names. So we're going to use 2 parameter files. A bunch of lookup table. So we're going to have a parameter file of what our lookup tables are and a parameter file of what our aggregation tables are. So we want to calculate our aggregates at 5 different levels. So we're basically creating a data set which tells us what the table lookups are going to be. So for the hash table, this is the table lookup. Yes, this is the table lookup table. It's telling us the hash table games is going to have these columns and game SK as a key. The hash table players has these columns and it tells us what the key is. So we're going to be able to loop through this data set and create our hash tables for our parameter files. We're going to be able to loop through this table, which tells us what our aggregation fields are. So, this is we're calling hash of hash, chapter 9 multiple splits. Once again, all of these programs are available for download, and they're on the GitHub project that Alan Bowe created. So we're going to create our hash of hash object, just like we did before. And we've added an additional field, calc and output is going to say, is this hash table used to do calculations and output, or is it just a lookup? So that's just a binary flag that we're going to use. We need an iterator for our hash object. And we need to define those non-scalar fields. So now we're doing a do loop to read the two data sets that contain our hash tables, our parameters. So without going through it line by line, I'm going to blast through it. We're going to read both the parameter files. If this parameter file is for a new hash table, we're going to create it. If the data set tag has a value, we're going to load it automatically so we don't have to load it. That's going to be used for our lookup tables. Define the key in the data fields, and then add it to our hash of hash table. So we now have our hash of hash table has, I think, 8 rows in it because we've got 8 hash tables. 3 are lookup tables, and 5 are going to be our aggregate tables. So we're now going to do our aggregates. We need to get the key for our games table. We need to get the key for our players table, and we need to get the key for our teams because we have to use the dot syntax. So games, players, and team are now hash object pointers for those 3 tables. Scroll through the comments quickly. Now our program to calculate the splits. We're going to define our PDV hash variables using if0. We're going to define the formats for our result variables. We're going to initialize everything to missing, just as we did before. We're then going to look up the needed fields about the game. We're going to look up the needed fields about the players. This is, what we did here is, baseball players can be traded from one team to another. So in data warehouse terminology, the players table is what we call a slowly changing dimension table. If you've written code to match with a slowly changing dimension table, you know how to do that. This is the hash code that will do a lookup into what's called an SCD type 2 table. Define the PDV host variables. And now we read the data. Once we've read each observation, we just loop through all of our hash tables and do the calculations. If not calc and output, in other words, this is an input table, continue says jump to the end of the loop. So we're now doing this calculation for all of our 5 levels of aggregation for each input row. And if we had 17 input parameter, 17 different aggregate tables, this code wouldn't change. Our parameter file gets bigger. That's what we mean by the parameter files get bigger. And then at the very end, we just output our multiple tables. Dropping the underscore, and notice that the data set name, we made hash table one of our fields in the hash of hash table. So we're now going to create output data sets for each of those. So this is our day of week splits, our month splits, our player splits, our player month splits, and team. And if we wanted to do another split calculation, we add rows to our parameter file. We don't have to touch the code. And that's the whole point. I'm a programmer. I don't like to write code.
So your commentator has to know all these splits and look to the top row and the splits.
Yes.
To use up there.
Yes.
There's a lot of splits.
Okay. Not going to talk a lot here about memory, other than to say memory can be an issue, but it can be dealt with. There are multiple ways to deal with it. Process the data in subgroups. You can use that either using where clauses or macro. You could subset the columns. You could reduce the length of hash variables. All of these and more are discussed in the book. Paul's got a couple of examples where he basically says, we have lots and lots of variables we want to look up, but we're going to just create a record identifier, and we're going to use set, which is the observation number, and we're just going to use set with the point. So we're going to store in our hash table the observation number in the external file that contains our data. And the set with the point option performs quite well. So that is very competitive. Which techniques work best requires a case-by-case basis. So once again, sorted or indexed, process each group separately, use where clauses, use business knowledge. One of our projects was that Paul and I worked on, was a point of sale for grocery chain, a large grocery chain, and they wanted to store the data based on their frequent shopper numbers, and they had like 11 million of them. Well, we couldn't fit 11 million with all of the other keys in a table, but 10%, you could break up the data based on the last digit of their number. So if we wanted to process data 10% at a time, just look at the last digit and loop through that way. If it got bigger and we needed to do it based on the last 2 digits or the last 3 digits, we could do that. So that's an example of using business knowledge to do that. You could also partition the data based on different sets of fields. Use set with the point, as I said, if you just stored that data. Reduce the size of the key fields using the MD5 function. MD5 is a hash function, not to be confused with a hash table. You can give any long character field to MD5, and it's going to give you a 16-byte field in return, which is almost guaranteed to be distinct. And if you don't believe that, you could use, there's a 256 hash function, which is probably overkill. Multiple fields, use the catx function to concatenate them. So you can reduce the size of your key to 16 bytes, no matter how long your source key is in terms of storing it in the table. Paul presented a talk about this. I'm going to fast forward through this. All of this is talked about in here. But you can partition the data. If you do an MD5 function and you get a binary value, you can break that up into any number of groups that you want using a formula that looks like this or like this. So I'll just sort of flash forward through this. So hash tables can be more efficient. I'm going to do this quickly because I want to get to the last couple of slides. We want to augment our pitches data with the pitcher's team's name and whether he throws left or right-handed. We want to preserve the original order of the rows. The player's data set contains that information that we want. The team's data set contains that information. The traditional approach requires multiple sort-merge steps for complex SQL queries. And I'm going to scroll to the end to get the timings. So here is, I think, this is our sort merge. Traditional elapsed time, 2.715 seconds, not a lot of time. The hash table approach, 0.48 seconds. once again, we'll make the presentation available so you can see those slides.
Sorry, I'm going back a slide. That's not a SAS message, is it?
What? No, this is not a SAS message. I put both of them on here. This is a SAS message. This is Don's annotation.
Should use a different color.
Point noted. Hey, I was a math major. I'm a geek, you know. I did spend some time in marketing when I worked for SAS way back when, and I learned a little bit. But going back, one of the other things that Paul and I decided to do about this book is, as we got reviewer feedback, it was, well, did you think about talking about X? Did you think about talking about Y? I said, you know, if we're going to explain, and part of this was features of SAS that we were taking advantage of, says, you know, if we're going to have to spend pages talking about the features of SAS that are particularly useful for the hash object, we're never going to get to talk about the hash object. So we decided we were going to write articles at communities.sas.com about this to expand upon the content of the book. So as of now, we've got 9 articles out there, one on debugging techniques, generating the sample data. This was, I think, the original one we pointed to that has a description of all the classes of example, splitting the data set up. That was our question before. Set statements, compile time, function, some examples of performance. Here's Alan's efforts to make the Bizarro ball data easier to access and create. One of our readers commented us and said, I've got some questions about this, can you help understand it? So we had a back and forth discussion. His name is Jim Sattler. So we said, okay, Jim, now that we've gone through these 17 emails with you, would you mind summarizing it and making an article on communities.sas.com? And then, see, it says 22 minutes ago. I added this slide to the PowerPoint this morning. We added an example that uses hash of hash to create calling hierarchy documentation. Right now I'm working on a project to help a client upgrade from 9.13 to 9.4. It is absolutely, positively the most badly designed and badly implemented application I have ever seen in my life. The macros are spread across 24 directories, no concept of where anything are stored. Some of the directories names have programmers' names in the path. So I had to write a program to read all of the code in using wildcard so that I could search it. And then I said, okay, well, I need to create a calling hierarchy. So that's what that article is about, a simple data structure of, for each programmer macro, what does it call, at what line numbers, and that particular program will create a calling hierarchy document for you. And yes, it uses hash of hash. So I wanted to highlight this one because of the performance issues, and highlight this one because it's brand new. And we are going to continue, Paul and I are going to continue to write articles, add them to communities.sas.com. So please check them out. And as I said, that's how we started our conversation with Alan, because, you know, he greatly improved the mechanism to download and create the data for the book and all of the programs. So thank you for that.
But you could have been doing other work.
Does anyone have any questions for Don? I've got one. Can you tell us the story of how the hash object began?
Now, the hash object began by Paul in the late 90s needing to use something like the hash object, and he wrote it using arrays that used binary values as the keys. So Paul Dorfman actually wrote data step code that implemented the hash object before SAS did.
He wanted a faster lookup.
He wanted a faster lookup because of the nature of his data, and none of the standard techniques worked. So he wrote, and this was all discussed on SASL back in 97, 98.